Okay. Here today we're going to be talking about muscle contractions. It all starts in the motor neuron, which has an action potential that goes all the way down to the synapse. It then relays this message through neurotransmitters that connect to receptors on the sarcolemma. The sarcolemma then sends the action potential all the way down to the T-tubule. The T-tubule then relays this message to the sarcoplasmic reticulum, which is using ATP to actively transport calcium ions into the sarcoplasmic reticulum. And when the signal finally reaches it, all the calcium is released. This calcium then travels to the sarcomere and connects to the troponins.
In the sarcomere, there's the actin and the myosin. Myosin are thick filaments with myosin heads that will link to the actin, and the actin are thin filaments with binding sites for the myosin head. The thick and thin filaments both lead to a banding pattern. The actin is composed of actin, troponin, and tropomyosin, while the myosin is composed of many myosin heads. Calcium bonds to the troponin, causing the active sites to be revealed. When the myosin heads bind ATP, it hydrolyzes it to ADP and PI, which is the phosphate ion. This then changes the shape to a high-energy configuration. The high-energy configuration allows the myosin head to bind to the actin, forming a cross bridge. Myosin then relaxes to a low-energy configuration but remains attached to the actin. This is called a power stroke. The actin is then pulled to the center of the sarcomere, and more ATP is required to break the cross bridge to relax the muscle. Rigor mortis happens because when at death, all the calcium releases. There is no ATP to disconnect the cross bridge, so it cannot contract, so the muscle is really stiff.